Good morning and welcome to lesson 6-4. What I first want you all to do in this lesson is take a look at the two right triangles here on this page. What I want you to do first is to find the missing sides of both of these triangles by using the Pythagorean theorem. Then once you've done that, I want you to go through and find the perimeter of both triangles and the area of both triangles. So take a moment to do that now, pause the video, and fill it in here in a second. So let's take a look at this now. We've found the perimeter and the area of both of our triangles, and now I want to look at the ratios of perimeter and the ratios of area. So perimeter, we have a ratio of 24 over 36, both of which reduce by order of 12, so I get 2 to 3. And area, I have a ratio of 24 to 54, which both reduce by an order of 6 to 4 over 9. So if I even just look at the sides, let me look at my shortest sides as a ratio. If I have 6 over 9, that also reduces to 2/3. So we can draw some conclusions about this right now. If I know that two figures are similar with a scale factor of a over b, then the ratio of their perimeters is also a over b, but the ratio of their areas is a squared over b squared. Let's take a look at an example of this. Ms. Robb is enlarging photographs for her wall. She wants the side lengths of the new photos to be 3 times the length of the side lengths of the old photos. How many times larger is the perimeter of the new photo? How many times larger is the area? So my ratio of new to old is 3 to 1. That's my A over B, which means that the perimeter is also going to be in a ratio of 3 over 1, which means that it will be 3 times larger. However, my area is going to be in a ratio of a squared over b squared, which is 3 squared over 1 squared, over 9 over 1. So my area will be 9 times larger. We have really similar things when it comes to three-dimensional figures as well. I want you guys again to go through and calculate everything in the table first. So take a minute and do that on your own right now. So when I go through and I fill in my table, I get the perimeters of all my bases, the areas of both the bases, the surface areas of both figures, and the volume of both figures. We could take a moment to determine whether to determine that these two figures are similar by comparing their corresponding side lengths. And we'd find that the ratio of 2 to 4 is the same as the ratio of 2 to 4 is the same as the ratio as 3 to 6. So these two figures are similar. So let's take a look at each of these concepts. Perimeter. The perimeter of my base, or actually let's look at a side length first. When I look at my sides, they're in a ratio of 3 to 6, which is 1 over 2. That's my A over B. When I look at perimeter of the base, they're in a ratio of 8 to 16, which again reduces to 1 over 2. That's still A over B. When I look at the area of the base, they're in a ratio of 4 to 16, which is 1 over 4. That's a squared over b squared, right? 1 squared over 2 squared is 1 over 4. Then when I look at the surface area, they're in a ratio of 32 over 128, which if you pulled out your calculator, you'd discover that is a ratio of 1 over 4, which again is a squared over b squared. And finally, when I look at volume, they're in a ratio of 12 to 96, which is going to reduce to 1 over 8. That's a cubed over b cubed. So when I'm drawing conclusions down here, the ratio of their corresponding surface areas is a squared over b squared, while the ratio of their corresponding volumes is a cubed over b cubed. So let's take a look at some examples. There are two similar cones, one of which has a volume of 250 pi feet cubed, the other of which has a volume of 432 pi feet cubed. What is the scale factor of the smaller figure to the larger figure? So what we know here is that 250 pi over 432 pi is equal to my a cubed over b cubed, because we're talking volumes. So I'm going to go through and reduce this as much as I possibly can. My pi's cancel. 2 goes into both of these, so I get 125 over 216 is equal to a cubed over b cubed. Now I ask myself, what number cubed gets me 125 and what number cubed gets me 216? Well, 125, when I take the cube root of that, I am going to get 5. And 216 cubed, when I take the cube root of that, I am going to get 6. So 5, 6 is a over b. So the scale factor of the smaller figure to the larger figure is 5, 6. Now if I wanted to multiply my smaller figure by a number to get to the larger figure, we would use 6 over 5 as the multiplier. So now what is the ratio of their surface areas? Well, the ratio of their surface areas is going to be a squared over b squared. So I take my a over b and I square both numbers, and I get 25 over 36 as the ratio of their surface areas. Another example. A cylinder is similar to a larger cylinder. The scale factor is 1/3. Okay, that's my a over b. The surface area of the smaller solid is 30 pi, and the volume of the smaller cylinder is 24 pi. What is the surface area and the volume of the larger cylinder? So this is actually 2 questions, which I'm going to treat separately, and then we can come back and draw our conclusions at the end. So let's do surface area first. If my a over b is 1/3, then a squared over b squared is 1 over 9. Well, I know that 1 over 9 relates to the ratio of the surface areas. Well, they tell me that my smaller solid has a surface area of 30 pi, and I don't know the larger solid, so I'm going to make it x. So I'm going to cross multiply. 1x is just x, and 9 times 30 gets me 270 pi. Well, 270 pi units squared is the surface area of the larger cylinder. Now let's take a look at volume. If a over b is 1/3, well, volume's related by a cubed over b cubed. So that's 1 over 27. They tell me that the volume of my smaller cone is 24 pi. So 1 over 27 relates to 24 pi over x. So I'm going to cross multiply. I get that x equals, and I'm just going to type 24 times 27 here in my calculator to get 648 pi units cubed as the volume of my larger solid. So that's the end of the notes. Take a look at the MML and write down any questions you might have for your teacher. Thank you very much.